In this lecture, we'll see what are the functionalities of IDPS, what are the categories of IDPS available, how these IDPS will help us in safeguarding the network assets. Will IDPS will work on its own, or will they require any other support to work? So these are the aspects we are going to see in this lecture. So here the role of intrusion detection and prevention systems in network defenses. We have seen the last virtual private networks lecture that VPN requires a firewall. That means firewall is the main one that that is required for the VPN to work. In the same way, the IDPSs must be placed behind the firewall always. For example, in this diagram, if you can look at it, the remote user via internet, if they want to access the organizational network, then there will be a firewall will be placed. So the firewall will regulate the traffic which to be entered, which to be allowed to enter, and which to be restricted. In addition to the firewall, so that is behind the firewall, this intrusion detection and prevention systems will be placed, which will keep track of the traffic which is coming into the internal network. So that means like how VPN require firewalls, like that IDPS will also require firewalls to set up. That means firewall is one which is the commandable one that need to be configured correctly, and which will based on which many other security systems will take the help of the firewall rules and policies, so that they can accurately identify the malicious traffic. So goals of an intrusion detection and prevention system is like this. An IDPS should be able to access large volumes of traffic or system activity to find signs of unauthorized access. That means it should be in a position to, it should be a sharp smeller of the traffic. That means the gigabytes or terabytes of traffic that is coming into the network must be sniffed with a high accuracy. That is what the goal of IDPS. If you want to design your own IDPS, again, this is the main criteria. Record its findings in a log so that administrators can examine past activity. That means IDPS should also provide a log at what time what packet has sniffed, or what packet has examined, or what packet has opened and reassembled. So these kind of things, this kind of information must be maintained by the IDPSs. Some traffic will be there which will try to evade the firewall. For example, stealth scan or the fragmentation scan done by the attacker that will evade the firewall, or that will not record any log in the firewalls. But such kind of traffic must be recorded at the intrusion detection and prevention system. So that means even though some traffic was escaped from firewall, but it should not be escaped from the IDPSs. So in such a way, the designing of the IDPS must take place. Detect and record unauthorized accesses without compromise to produce evidence admissible in court. This is very important, that how you can claim that so and so attacker or a so and so organization wants to conduct attacks on so and so servers. So this IDPSs, if IDPSs records the log, and that will be useful for producing as an evidence in the courts, so that the related compensation can be obtained. Respond almost immediately. That means it won't take much time to respond to the unauthorized access. That means there should not be any time gap between the occurrence of the unauthorized access and reporting to the administrator, that is raising of alarm. Make itself and systems it protected as inaccessible as possible to attackers. That means the systems, that is the internal network that was guarded by the IDPS, must be protected so that they are inaccessible from the possible attacks by the attacker. These are the 5 ultimate goals of the intrusion detection prevention systems. The main categories of IDPS are like this: anomaly based intrusion detection systems and signature based intrusion detection systems. Anomaly is nothing but which is an abnormal behavior. Whenever an abnormal behavior observed, then detecting of such abnormal behavior to show it as an attempt to attack by the IDSS will be the ultimate aim of the anomaly detection. So when can you say an anomaly detection will occur, or whenever you can say the anomaly will arise? So in general, anomalies will arise when there exists a wrongdoing. It is just like accessing of a manager's account by from a normal client account or normal peon account or maybe clerk account. So if the clerk account is want to escalate the privileges or want to try to access the uh, resources that are intended for the manager, then it is an anomaly. So a clerk has to perform or access the files or folders which is intended for the client itself, intended for the clerk itself. Then it is a normal activity. But if he is doing some abnormal activity, then it is said to be the anomaly. So for that purpose, the IDS will make use of profiles that describes the services and resources each each authorized user normally access. For example, clerk has to access only file system of a specific files or specific folders. But if he is trying to access the folders that are intended for the manager, so because of the recording of the profiles which are already available in the system and which are fed into the intrusion detection systems that describes the services and resources each authorized user normally access, based on that it will identify that whether the activity is normal or abnormal. Network baselines are associated with profiles. System can monitor profiles for suspicious activity that do not fit the profiles. So how this will be recorded? Obviously, this will be observed with the help of the log recorded by the operating system, or the IDSS will have the access to the logs of the activities that are happening. So the IDPSs can create baseline by monitoring network traffic to observe what is considered normal or abnormal. So in this process, we have if the system of the profiles and access matrix is fixed, then it is not a big problem to identify the anomaly. But some attackers will try to gain the unauthorized access in an intelligent way. In such a cases, how you can detect the anomalies? So in such a cases, you need some intelligent techniques to detect the anomalies. That is what the data mining or machine learning techniques that you use, or you are supposed to make, you are supposed to apply such techniques to intelligently detect the anomalies with high accuracy. Because if you have many false positives, then it is a very weak system and will give the alarm for every action, every small wrongdoings, or we can also small wrongdoings for every what you call activity happened by in the system. So that is the reason anomaly based intrusion detection is a tedious task. However, if the access matrix and policies are strictly made, then anomaly detection can be made easy, which is also called as supervised anomaly detection. That means already the matrix of policies, security rules, everything is fixed. So the reason it is said to be supervised. But when dynamic wrongdoings are happening, then unsupervised way of accessing is required. We will see these concepts at the end of this course, that is intelligent anomaly detection or intelligent intrusion detection systems. So what the anomaly based intrusion detection systems will do is, if profiles are incomplete or inaccurate, then the four terminologies that are popular in the intelligent intrusion detection systems, such as false positives, false negatives, true negatives, and true positives. Many students will confuse in this particular matrix. That is the reason we will call it as confusion matrix. So how to remember this without forgetting? The first and baseline that you must remember is, what is your problem statement? If the problem statement is to identify the attacks, that means it is a positive statement. The baseline for assessing the confusion matrix is the problem statement. We can also say, what is your hypothesis? The hypothesis is to identify some attack. Say for example, hypothesis is to identify denial of service attack. And alternate hypothesis is the system is genuine. So the hypothesis or the problem statement is identifying of denial of service attack. So that hypothesis or that problem statement you should consider as a positive statement. If you put false before that, that means you are concluding that that problem statement is wrong. That means your problem statement is to intended for identifying of the attacks, but your result is coming like that, false positive. That means IDPS sends an alarm that false positive legitimate traffic rather than the actual attack. Okay, so here positive means actual attack, but what it is giving you report as false attack. That means even though it is an actual attack, but it is giving you as a legitimate traffic. False negative. Your problem statement is positive. That means identifying of attack. So opposite of positive is negative. That means opposite of your problem statement is the traffic is legitimate. False negative. That means genuine attack is there, but IDPS does not detect it. That is what is called false positive. So false negative. That means the confusion matrix should be understand based upon your problem statement, and your problem statement must be considered as a positive statement. Based on that, by making it as a baseline, you have to go for either it is false positive or false negative. False positive is nothing but your finding is not according to the problem statement. That means you are intended for detecting of actual attack, but you are proving it as your finding is proving it as a legitimate. Where in case of false negative, it is a reverse. That means it is a genuine attack, but your IDPS does not detect the genuine attack. This is called false negative. True negative is nothing but legitimate communication that does not set off an alarm. True positive is nothing but used to describe a genuine attack that an IDPS detects successfully. That means true positive is nothing but your problem statement is actually satisfied with the findings. Okay, I hope by this time you got a clear understanding of what is meant by this confusion matrix. Majorly, this confusion matrix will be popularly used in case of intelligent anomaly based intrusion detection systems. Whenever you use any intelligent things like machine learning, data mining, deep learning, these kind of things, methods, then there you will use this confusion matrix to project your accuracy of identification or accuracy of your model. So I hope by this time you people got the understanding of what is this confusion matrix. So the next category of anomaly intrusion detection other than anomaly is signature based. That means in the signature detection there is a predefined signature patterns will be there that will be loaded into the IDS databases. That means many IDSs will use the database of signatures. Whenever the traffic pattern is not matching the signature, then it will raise an alarm. It is just like you might have signed a check and you might have given to anybody for claiming that check. If the person went to a bank and if it is given for the deposit, then the bank people will verify the signature on the check with the signature which is already enrolled in the system. If there exists any mismatch, they will ask you that okay, the signature is not matched. And if you are the person over there, and that means the one who are the account holder over there, then the bank people will ask you to re-sign on the back side of the check. Again, they will tally if the signature is matched with the already digital the signature which is already available in the computer, then they will say accept, otherwise reject. In the same way, you will load the signature patterns, that is traffic signature patterns in the IDSs. So where you will store it, the IDSs will take the help of the databases like MySQL or PostgreSQL, in which you will load the signatures. Some IDSs will take the help of the XML files for getting the signatures to be verified or loading of the signatures. Some IDSs will use the plain text. Always better than is always we all know that plain text is the databases are better than the plain text. So IDSs usually will take the help of the databases for loading these signatures. So what is this signature? During the discussion of the packet format and packet signature format, or we can say packet structure, we have seen that first there is a preamble, then header length, then so and so port number, then IP address, then checksum, then destination port address, destination port number. So this kind of thing we have seen. So this is what the pattern is. Okay, this is what the pattern is. Again, in that we have seen the code bits. Okay, what if the code bit is enabled? Okay, what type of code bit? Which code bit results to which signal? In case of TCP, in case of ICMP. Okay, so this is the format we have seen. The same format will be fed into the IDS databases, and whenever the traffic was sniffed, like how the Wireshark will sniff the traffic, in the same way IDSs will also use the packet capturing. So IDSs capture the packets just like Wireshark, how the Wireshark will capture the packets. So it will capture the packet and will match with the IDS will match with the signatures that are already loaded into the IDPS. So if the signature is mismatched, then the IDPSs will raise an alarm saying that signature was mismatched. So this is what the signature based detection is. In the case of anomaly based detection, there is a strict policies and access matrix will be available. By looking at that, anomalies will be detected. Where in case of signature, traffic mismatches, traffic pattern mismatches, or packet pattern mismatches, this kind of things will be this kind of things will be checked and will be placed in the databases of the IDS. So whenever the traffic was sensed, then it will compare with the signature which is already loaded into the database. So triggers alarm based on the characteristic signatures of known external attacks. Signature based IDPS best for companies that wants a basic IDPS and mostly concerned with the known attacks. That means the signature based attacks signature based intrusion detection systems will not detect are not capable of detecting unknown attacks, which are already known attacks. For example, the synchronous attack, RST attack, or finished signal information attack, or maybe stealth scan, or these kind of things can be detected by the IDPSs, that is signature based IDPSs. Why? That means they will only compare the signatures. If the signature was mismatched, then they will raise an alarm. So the SNOT IDS that we'll discuss in this course is a kind of signature-based IDPS. It is a very best IDPS so far, and a leading IDPS, open source IDPS in the market. And one thing is how you say that this is a known attack. So this known attacks you can identify via common vulnerability databases available online. You can go to the website exploit DBs, common vulnerability databases, which is also called as CVS repositories. You may search in the Google that CVS repositories or exploit DBs so that you will find the databases of the vulnerabilities. Whatever the vulnerabilities available in those websites are all known attacks. Whenever you search for a particular vulnerability related to a particular application, either it may be a HTTP, HTTPS, DNS, or maybe any other thing, then attack signature will be given there. Based upon the attack signature, the signatures will be framed and will be feeded to the IDSs so that from the next time onwards, whenever any traffic with the same signature was mismatching of the signature was occurred, then IDSs will easily detect that wrong pattern. So that is the reason this signature-based IDSs will be useful for the companies that want basic IDPS and mostly concerned with the known attacks. So if you are as a software engineer or as a computer science engineer, if you want to start your own company and you want to place an IDPS for that, so this signature-based IDPS is the best solution. Among this, Snot is a very easy and a very easily configurable, open source, freely available, and efficient IDPS available. So you may make use of that and you can install in your organization. That is a startup or somewhere. Network engineers research well-known attacks and record rules associated with each signature. Since attacks, that is the common vulnerability databases will be updated every day, so you may also periodically update the signatures. That means you may add new signatures, maybe very old signatures may be removed. So how can you remove the old signatures? That means you can remove the old signatures whenever you update your systems. So whenever you update the systems, then the old pattern of network traffic or old vulnerabilities may not be exploited. So you can remove the old signatures and you can feed the new signatures based upon the known attacks. This is what we call signature should be updated regularly. Let us see the advantage and disadvantage of anomaly and signature based detections. Anomaly based detection, because an anomaly detection system is based upon the profiles and an administrator creates, the attacker cannot test the IDPS beforehand and anticipate what will trigger an alarm. So we can say it is as just like a unknown thing. That means you don't know what kind of wrongdoing will happen. So beforehand you cannot test this IDPS. So in such a way we can say it is a kind of intelligent like that they're projecting. Disadvantage is configuring the IDPS to use profiles of network users and groups require considerable time, because you don't know when the normal user or group user will try to perform or will try to access the files or something which is not intended for him to access. So it will take some time uh, for exploring or testing the efficiency of the anomaly detection methods. As new users and groups are created, IDPS profiles can be updated to keep up with these changes. The disadvantage is updating IDPS profiles can be time consuming, because in any organization the employees will come, go, and maybe changed, okay, maybe promoted. Okay, these kind of changes has to be adopted and this to be updated in the system. Because an anomaly detection system does not rely on the published signature, it can detect new attacks. That means a new patterns may be identified. Okay, whenever the new pattern is identified, then that can be feeded again in the signature based databases to perform. And some hybrid IDPSs will be there, which will take the help of the both anomaly and signature based, so that they can do efficiently. The definition of what constitute normal traffic changes constantly, and the IDPSs must be reconfigured to keep up these changes. So the administrator will be having a lot of work in such cases. The system can detect attacks from inside the network by employees or attackers who have stolen employees' account. After installation, IDPS must be trained for days or weeks to recognize the normal traffic in case of anomaly detection. So that means that training is a difficult part. Our training is a time-consuming part in case of anomaly detection methods. In case of signature detection methods, signature-based IDSs, this approach makes use of signatures of well-known attacks. The database of signatures must be updated to maintain IDPS's effectiveness. Otherwise, they will not work. That is what the disadvantage. In case of signature based, this IDPS can begin working immediately after installation, because already the rules were fixed and rules were entered, and immediately it will start and it will sniff the traffic and will compare with the already feeded signatures. New type of attacks might not be included in the database, so you must be take care of that. That means signature based IDSs are are useful for the known attacks. This IDPSS is easy to understand and less difficult to configure than an anomaly based system. By making minor alternation to an attacker, the attacker can avoid matching the signature of the database. So this is what the disadvantage in the case of signature detection. So that is the reason we are going to place a layered one, either combined with the anomaly and then followed by the signature, or in the firewall itself we will place the rules, then by the IDPS will be detecting such wrong patterns. So this kind of thing, this kind of arrangement, a layered defense arrangement must be made. In case of signature, each signature in the database is assigned a number and name, so that the administrator can effectively or can specify which attack should set off an alarm. Because a misuse-based system requires a database, expensive disk storage space might be needed. So you need to dedicate a disk for loading the signatures and making use of those signatures. So every type of IDPS will be having its own advantages and disadvantages. But the only thing is, depending upon your organizational requirement, which is required, that need to be adopted. In IDPS, again, you will be having different kinds of analysis, like how the firewalls will be having the stateful and stateless packet filtering. Like that, in IDPS also you'll be having stateful protocol analysis. Like for example, stateful protocol analysis means the protocols that are the traffic that is coming from the established connections will be checked and verified. In the same way, here stateful protocol analysis, information gathering about a connection. When an IDPS receives a packet, connection information between the host and remote computer is compared to entries in the state table. That means only the established connection related details will be checked. State table maintain a record of connections between the computers, including the source and destination IP addresses and ports and protocols, these kind of things. Event horizon, entire length of the attack. IDPS need to maintain state information during this. So stateful protocol analysis approaches will be like this. Traffic rate monitoring. That means sometimes the traffic will be slow, which may be very slow in coming into the network. But all of a sudden the traffic rises. So what may be the reason? There may be several reasons. Like the attacker may perform the fragmentation attack. The attacker may be using Nmap tool there for scanning the ports or scanning the system. So like that, you can make a prediction. So if IDPS detects sudden increase in the traffic, it can stop and reset all TCP traffic. This is the part of the stateful protocol analysis. Protocol state tracking. IDPS maintain a record of connection states and allow packets to pass through if it is an established connection. This is very, very important in case of stateful protocol analysis. Dynamic application layer protocol analysis can identify applications not using standard ports. That means you might have developed a web application, but the port is not 80 or 443. You may be using some other port. Then immediately it will detect. The request is of type HTTP and FTP and TCP, and port is not 80 or 443. Then immediately it will detect it. IP packet reassembly. So whenever the IP packets were fragmented and sent, can reassemble fragmented packets to prevent fragments from passing through the internal network. And IDPSs have the capability of reassembling of the fragments and will decide whether after reassembly the packet is a genuine one and can be interpreted by the operating system or not. If it is genuine one and can be interpreted by operating system, then it will allow the fragmented packets to enter into the OS. Otherwise, there itself it will raise an alarm and will try to drop that fragments. The reason is many of the operating systems don't have the mechanism of wrong reassembly. That is, if the ending bit is not set to off, or the fragments have not been correctly mentioned, or payloads are not being correctly mentioned, then the operating systems may crash. So that is reason IDPSs will help us in checking the fragments, and after reassembly the fragment can be worked or not. This will be checked by the IDPSs and will be forwarded to the operating systems if it is okay or successful. So here examining the components of IDPS. The main components of IDPS are network sensors or host-based agents. Here sensor is nothing but is not a physical sensor. Sensor is nothing but the sniffing of the traffic. So here sniffing of the traffic in the sense, in case of Wireshark, you use PCAP tool. So the PCAP, maybe WinPCAP or any other PCAP tool you use. First the PCAP will be installed, then Wireshark will be installed. So this PCAP, what it will do is packet capturing tool. It will sniff the traffic on the network device or your network interface card, which may be incoming traffic or outgoing traffic. So like that, here sensor is nothing but the sensor is a software or a kind of sniffing tool will sniff the traffic on the ongoing network or which is onto the network interface or router or switch where it is placed. So network sensors are host-based agents. Detection and prevention capabilities, command console, maybe a graphical user interface or maybe a command console with which you can communicate with the IDPS. Database servers that store attack signatures or behaviors. So IDPS will be having these four components. Sensor agents functions as an electronic eye for an IDPS, in which you will be having categories like host-based intrusion detection prevention systems, network-based intrusion detection prevention systems. If you place the sensors and related analysis at the host level, that is at the individual computer level, then those are said to be host-based IDPS. SNOT can be used as the network-based IDPS, and also you may use it for the host also. Host-based IDPS is installed on a single host computer as an agent built into the IDPS software. Where in case of network-based, you will place these IDPSs at the network level, maybe at the router level. So sensor is a hardware or software that monitors the network traffic in real time at the network level. Attacks detected by the IDPS are like this: single session attack, which is isolated attempt. That means only one time the attack may be performed. Such kind of things will also be detected by the IDPSs. And multiple session attacks. That means repeated attacks will also be detected by the systems, IDPS systems. So sensors should be placed at the common entry points, as just now I told you, at the internet gateways, connections between the one network to the another, remote access servers, or at the virtual private network devices. We have seen the VPN routers will be there. So at the VPN routers, you may place these sensors. So sensors could be positioned at either side of the firewall. That is, behind the firewall is more secure location. So it is always recommended that IDS must be placed behind the firewall, not the before the firewall. IDPS management server, central repository for the servers and agent data. You may keep a central IDPS management, but sensors can be placed in multiple places. So what the advantage of this is the sensors will only sense the traffic with a high accuracy, and that sensed traffic will be sent to the IDPS management server. So wherever these sensors are there, their IDPSs will not be there. Only sensors will sense the traffic and will send to the IDPS management server, which is maybe a centralized repository. There the traffic will be analyzed and alert will be issued. Just like this, here option 1, this is a router, and here the remote user, which is from the internet or somewhere. So whenever the option 1 is between the remote user and internal network. So place a sensor just before the firewall and maybe after the firewall. Option 2 is between the branch office and internal network. Okay, so this is the way. But IDPSs must be placed only after the firewall. Sensor may be placed before and after, so that IDPS can verify what is the intensity of traffic that will come into the router. Okay, or maybe a firewall if you place here. Okay. Next, what is the capability of firewall, or with the firewall rules, what type of traffic was filtered and captured at the other end can also be judged. But in general, if you have a routers like this, the sensors may be placed like this before the entry of the router and after entry of the router. Then after router, whenever it is going to the branch office or maybe internal network, between two internal networks again a sensor may be placed, because you cannot expect the attack may also happen from the internal. So means if internal misuses can also be detected, not only from the external, but internal misuses will also be detected whenever you place the sensor within the network. And it is always recommended not to place the sensors for the IDPS before the firewall. Okay, position sensors behind the firewall in the DMZ. So firewall and here sensor and DMZ, and here sensor and internal network, sensor again internal network. So here we are not keeping entire IDPS system, only sensor we are placing. Only it will, like a packet capture, it will only capture the packet and will send to the IDPS system, which is a centralized server. So on what basis you can assess the detection and prevention capabilities of the IDPSs? It will be like this: when selecting an IDPS, consider the following: threshold. Threshold in the sense value that set limit between normal and abnormal behavior. That means if continuous 3 wrong patterns were observed, raise an alarm. Okay, or if continuous 5 observed, raise an alarm, like that. Blacklist, that is a facility of allowing the malicious traffic to be blocked for some time. So that list of entries that have been associated with malicious activity. Whitelist, which are harmless and which can be let into the internal network. Alert settings, specifying default priorities or severity levels, determining which prevention capability should be used for certain events, and specifying what information should be logged. This has got the alert settings. Prevention capabilities, IDPS can be configured to take preventive countermeasures, like if abnormal traffic is coming into the system. Abnormal means in the sense if there is a sudden rise in the traffic flow, then it may go for resetting of all network connections when an intrusion is detected. Okay, if it finds that this is suspicious traffic which is highly flowing into the network, then immediately it can reset all network connections, and when an intrusion is detected. It is just like a actuator in the sensors network. If something was gone wrong, or if something was sensed wrongly, then immediately the actuators will work. It is just like in a heating boiler. If the temperature crosses 1000 degrees centigrade, immediately the cooling solution has to be poured. Immediately the boilers will get cooled. So in the same way, here also, in software point of view, this IDPS point of view, whenever a wrong pattern or whenever a wrong traffic was observed, abnormal traffic was observed, immediately it has to take a preventive action, okay, so that the impact of the attack can be reduced or maybe nullified sometimes. Some IDPSs allow administrator to specify which measures should be taken for each type of alert. Here, the intelligence part will come into the picture. There may be several methods to take an action, but it may give you one. The administrator may be given some options, but that may not be sometimes true always when if you won't use intelligent techniques. So here is the intelligent technique. Here it is opening a research area that what type of remedy or what type of action need to be performed when certain type of attacks are performed. Some have simulation mode in which all prevention capabilities are disabled, but generated reports use it to fine tune the prevention capabilities. So instead of doing in real environment, some simulation modes will be used, which will give you the uh, remedies, or which will give you the possible actions to be considered. However, this is simulation mode. Maybe still it is not a viable solution because sometimes simulation results may also be wrong. So this is the prevention capabilities. That means ultimately the prevention capabilities is to be in a position to the IDPS should be in a position to recommend the possible action that can be performed to the administrator if in case of any intrusion is detected. That is what the ultimate goal of this prevention capabilities. And another component is command control. The command control is especially used for the giving of the commands. Either it may be graphical user interface or maybe command line interface. Not is an IDS will be having command console. That means you will give the commands from the command prompt. So which will help the administrator to analyze the logs or to feed the signatures into the IDPSs. And database of attack signatures. Usually, these databases of attack signatures will be prepared by by getting the recent attacks updated in the common vulnerability databases, and from there, these attack patterns will be designed and will be feeded. So, signature detection IDPSs references a database of known attacks, and if traffic matches the signature, then it sends an alert. Always, it is recommended to keep the database updated. Anomaly-based IDSs will store the information about the user profiles in the databases. So here is an example of security focus tool where the database will be loaded with the attack signatures. So here, as I told you, that is CVE, Common Vulnerability Database. So they are going to get the data, recent attacks from the Common Vulnerability Database, and will be loaded into their database. The security focus online database of known vulnerabilities. This is maintained by Symantec, and you may also go to the exploit DB or CVS repository to know what are the known vulnerabilities. I hope by this time you got the idea of what are the components in IDPSs and how these IDPS components will work. So these are the theoretical parts, and you need to remember the various components that are used in this, and we'll see the component by component when we discuss this not intrusion detection system, which can be used for both the host and network-based intrusion detection.